So welcome everybody to the virtual star party for May 6th, 2012. And tonight we've got two deep sky telescopes happening. We've got Gary Gonella in Los Angeles, who's got dark skies. We've got Peter Lake, who is in Australia, but he's got his New Mexico telescope controlled virtually. And and Stuart is going to be joining us as well. So, and then for color commentary, of course, we've got Dr. Pamela Gay, my co-host on Astronomy Cast, and we've got a new participant this week, also an astronomer. We've got Scott Lewis. So, Scott, why don't you give people an introduction on who you are?
Well, I'm Scott. Nice to meet you. Right now I'm actually in school for astronomy with physics in mind, so astrophysics. I am in the middle of two research projects, one for measuring X-ray radiation as you go through the ozone layer, and one unknown for aeronautic engineering at Cal Poly Pomona in California.
That's really cool. And so how far until you're a doctor as well?
A long while. I've got some time ahead of me. I've gone back to school a little late in my life. I was been a firefighter EMT for about 8.5 years, and due to our economic downturn, I decided to go after my original passion in life, which is the cosmos.
Really? So you're firefighter turned astronomer?
Yes.
That is awesome.
I think I've always been an astronomer, but it's now just coming out.
Astronomer turned firefighter turned astronomer.
Exactly.
Yeah, that's awesome.
Total props.
So, and I've got a note as well. We've got probably Stuart Foreman's in San Francisco. He's probably going to be joining us, and possibly Ray Sanders. He's in, where's Ray located?
He drives out to Arizona, I think.
Yeah, he's in, I believe, Flagstaff, Arizona is where he's at.
Right. So it's a very West Coast oriented star party tonight, which is why we have to start so late. And I really apologize to everybody because as the summer goes on in the northern hemisphere, the nights are getting longer and longer, and especially where I live, we don't get it to be dark skies until like on the summer solstice, June 21st. It's dark until 10:30. So it's yeah, it's pretty crazy.
We need more Southern Hemisphere people, please. Southern Hemisphere people, come allow us to start earlier in the night.
Yeah, well, exactly. If we can get some Southern Hemisphere people, if we can get some people, more people even in the Eastern time zones, then I'd be happy to start it up later, and then the West Coast people to start up later. So, and there's Stuart, and Stuart has brought us Saturn. Can you hear us, Stuart? I don't think you can hear us.
That's gorgeous.
Isn't that awesome? I can hear him breathing.
Oh, there's us. We suddenly became meta.
Yeah.
And Peter, your image just split with half of you going to either side. That was a fascinating video glitch.
Yeah, I think I'm struggling with trans-Pacific broad bandwidth at the moment.
Yeah, you are really pushing technology to its straining it to its ultimate limit. So, as you control your computer telescope from Australia, and I am going to. Well, I don't know if you noticed. Hey, Stuart, can you hear me?
Yeah, I'm here. I'm here now.
Okay, all right. Your mic's a little hot. I don't know if you can bring that down at all. I'm hearing it's pretty loud for me, but maybe now that you've talked.
I'll just talk softer. How's that?
Sure. And we lost your beautiful Saturn view there.
Okay, let me see what I can fix.
The night sky.
So last night, Stuart was such a champ. We were trying to observe the moon, and well, the moon kept moving, and he moved his telescope 4 times for us trying to capture it, and then he was capturing Saturn and tree limbs, and it was all manner of natural, not disasters, but nuisances getting in the way of clear viewing.
Well, last night was the supermoon, right?
Yes.
Wasn't it
and it was a night for super science.
That's right.
Yeah, but not disasters.
Do you see the
nonsense? Yeah.
do you see it now? I'm sorry.
Nope.
Do you see it now? The Saturn. What are you seeing off my screen?
Just a blackness. Screen.
Okay. I'll keep working on it.
Okay,
Or
no
did
problem.
you find dark energy? Because that's what it looks like. Wow.
So then let's just start with what Gary's got, because Gary's been waiting patiently with this beautiful view of one of my favorite galaxies on the screen. So Gary, what have you? Now I know you've got a bit of an itinerary for us tonight, right?
I've got a few things listed. We'll see if...
Is it the same thing? Some sort of stuff we've never even looked at, and we don't even know what it's going to turn into?
There's a few that we haven't looked at. I'm going to try to catch the rosette and the monkey head before they go down, because this may be the last week we can see them.
Okay.
And they're pretty low. So this is M51.
Yep.
And it's a 2-minute exposure. So just finished the exposure, and I've moved the scope over to rosette. So as soon as we're done looking at this, I'll start another exposure.
That sounds great. So now that I've got two astronomers on hand, can anyone give us some information about M51, aka what's this? Is this the whirlpool?
It's the whirlpool.
Yeah.
So this is the quintessential grand design spiral galaxy, where we think that little neighboring spud off to the right in this image is actually responsible for the beautiful structure in the main galaxy, where the gravitational interactions drive what are called spiral density waves, which basically means you have these denser regions of stars and gas, and because they're denser, as material gets near them, it accelerates in, and then it gets slowed down as it tries to get back out. And so that extra time that material spends lingering in the arms is what causes it to look like the majority of the material is hanging out in the arms.
That was one of the things that was surprising. Like a lot of the times when we record Astronomy Cast, I kind of half know sort of what we're talking about. I have reported on space and astronomy news for a while, but when you actually explain to me how the spiral arms are really just these density waves, that they're not actually, that it's not like it's material rotating in the galaxy, but that it's actually just that's happening, but at a different speed. The whole galaxy is turning like once every, like the Milky Way is turning like once every. But
the velocity of the arms and the velocity of the material rotating have nothing to do with
each other, right? And that it's purely just almost like warps, gravitational warps in the disk. And
it's a speed zone.
It's a speed zone, that's slowly rotating around.
It's that suburban speed zone where you hit the suburbs and suddenly you drop down to 25 miles per hour from 55.
Yeah, and that causes these spiral arms to sort of they bunch up, and then you get these regions of star formation because this gas and dust has been collected together, and so. But in this case, right, this galaxy is actually interacting with another little...
Right, those two are gravitationally bound to one another, and there's actually a bridge of material between the two of them. So this is the system that someday will probably be one less beautiful system. But for now, we get to enjoy it while we can.
Well, and a wonderful thing about that, it's NGC 5195, and if you can get to a dark enough sky, us with non-large telescopes like Gary, you can actually see it with binoculars if you have clear enough and dark enough skies. That's one of my favorite things to look at when I go out to Joshua Tree, is to get a view at. And it's beautiful in and of itself, plus you get to see them interact together. It's just wonderful.
Well, we can hear Stuart.
And we can see Stuart while we hear him.
Well, why don't we go...
You can...
Yeah.
Do you see me or do you see the Saturn?
We see Saturn. It's your surrogate tonight. Yeah.
You're just a planet tonight. Well, let's move on. Let's move back over to we'll move over to Saturn now, and we'll let Gary pull something else up on the screen. And also, Peter, you had I think I saw a globular cluster there. So.
I love how random words show that you're Canadian, and globular cluster is one of them.
What? A boot?
Oh, so
well, they're globular clusters.
Globular clusters, eh? Oh.
That's a new Tim Hortons line. That definitely needs to...
I hear there's Tim Hortons in the States now. So.
There are.
Yeah, so you guys are doomed.
So Fraser, yes, I've got a globular cluster, M53. So can cover that when you're ready.
I'm ready. We're just going to go back to Saturn every now and then and just gaze at it. I think what's I go over this every week, which is that when you get a chance to look through a telescope and actually see Saturn with your own eyes, this is kind of what it looks like.
Yeah.
If you got a sort of a nice telescope, then you are going to get this. You're going to get I can just see some bands across the planet. I can just make out the Cassini division there, right?
Right.
Yeah, there's moments of clarity where you can make it out. And you can start to see the shadow of the planet off to the left a little bit.
Yeah.
I'm gonna take some videos of it and post online.
Yeah, and that's where this hobby really comes together, right? When you take the video that you're recording and then you render it all, stack it all down, and then you've got sort of the best of all of this whole entire video pushed together into one beautiful image. Yeah, this hobby, I've got to say, has got a lot of depth to it, because you can sort of, you can start with just visual observing, but to really take this to its ultimate level, you want to stick a camera up into your telescope and actually record things. So, now Oh, go ahead, Pamela.
There's just so many different ways to inadvertently get addicted. There's the astro-imaging side of it, which I know you and I have a soft spot for, where you basically go out and you spend what eventually turns into stupid amounts of money on cameras and lenses and tripods and telescopes that you're actually now using as lenses just to capture that beautiful image. Then there's the people who go out night after night doing science, observing for cataclysmic variables that are erupting, catching the magnitude of pulsating variables, looking for transiting planets, and everything in between. There's the people who get engaged to do education, and it becomes this way to feed all of your spare time to something for good, and it's just kind of awesome. And no human interaction required if you're not a people person. You can take your data in your driveway and ignore the rest of humanity and submit it online.
Well, and I think Peter is a great example of somebody who follows both of those paths. I mean, he takes these beautiful pictures, but he also is doing some science. So, Peter, what have we got here?
So, this is M3. So I'm not sure if you can see in the large window of the screen there, but it's a great globular cluster. Now, the Messier catalogue is a catalogue compiled by Charles Messier, and he went about making a catalogue of objects that could easily have been mistaken for comets. So whilst this looks a fairly fuzzy object in the sky, these are all individual stars, and Pamela will tell us a little bit more about how globular clusters form. But Messier created a catalogue of these things, and some of them were galaxies, some of them were clusters, and I know, Fraser, you made the comment last week, we haven't had a look at many clusters yet, so tonight I thought I'd pick out a couple of good clusters. This one's M53. And so you can imagine like 100, 200 years ago when Charles Messier started his catalogue, the optics probably weren't quite as good as and brilliant as they are today. So there were some fuzzy objects in the sky that could be easily mistaken for comets, and this was one of them. And this is number 53 in his catalogue. So I think Pamela can tell us a bit more about globular clusters.
Well, the awesome thing about globular clusters is all the thousands of stars in this. Essentially, these look like dead bugs when you look at them through an eyepiece. Generally, all the thousands of stars in this faint, fuzzy blob of light, they all formed out of one giant cloud of material, and this means they all formed with the same composition. And they all formed at the exact same time. So this is the perfect stellar laboratory for running an experiment where you want to see how do stars evolve that all have the exact same composition but are a variety of different masses. And so we look at globular clusters that are each made out of slightly different materials, but all the stars within each of the globular clusters are identical. So this globular cluster over here might be extraordinarily metal poor. This one over here might be a little bit more metal rich. And when we say metals, we mean everything other than hydrogen and helium. We're just lazy in astronomy.
Yeah, that's
now the reason I say metal poor versus very metal poor is because these are some of the oldest objects in the universe. And so when they formed, not that many supernova had exploded yet. And so all of them are very, very different stars from our own sun. And for a while, there was a controversy about the age of the universe versus the age of globular clusters, where it looked a bit like the globular clusters, according to theory, were older than the universe, according to theory. And this meant somebody had to be wrong. Now, it turned out everybody was wrong. The universe was a little bit older than we thought. The globular clusters were a lot younger than we thought. And so it's now looking like these systems are probably about 11 billion years old. The universe is more than 13 billion years old. Life is good. Now, what's awesome about M53 in particular is this is one of the most distant globular clusters from the center of our own Milky Way galaxy. It's located about 60,000 light years out. And that means that it's orbiting in the same part of space where we're seeing some of the most nearby dwarf spheroidal galaxies, which have sort of the same number of stars and the same amount of mass, but look entirely different. So the Ursa Minor dwarf spheroidal galaxy, which is one of the smallest, is about 65,000 light years out. So it's neat to look at these two objects that formed about the same time. Both of them formed as a single burst of star formation, but kinematically they're wildly different. So I love these things. I did my undergraduate research on globular clusters, and so I'm going to shut up now because really I could go on.
Well, no, but absolutely. I love them the same way. I mean, you know, my favorite, right, is what, M13, the one in Hercules.
Yeah.
And again, you take a small telescope, and one of the first, you know, it's summer, it's warm, Hercules is going to be right up, and it's just one of the best objects, M13. Again, I think you can spot it with a good pair of binoculars.
Yeah.
And it's, you know, it's a fuzzy little blob in Hercules.
The middle.
No, it's over on the right-hand side. Like, it's over on the side.
Okay, it's in the middle of a small triangle of stars on the right-hand side.
Yeah, but it just looks great, and it's one of those great things. You know, when I have the telescope out, I'll go, you know, whatever planets are up. If the moon, if it's got a good phase, and if it's summer, it's Hercules. It's M13. It's, you know, the double. You know, it's the cluster in Perseus. You know, the ring nebula, if I can. That's the kind of stuff that you'll see in the summer. So hopefully, as we move towards summer, we're going to get a much better view of some of these objects. It's almost time to actually start seeing Hercules. So this is M3. You just switched.
I showed you this. So this is M3 now. So I saved the best one till last.
That's beautiful.
So that's a bigger one. This one's got quite a lot of colour in it too, with different. You know, as Pamela was talking, the different makeup of the stars in a really nice photo of a globular cluster. You can actually see the different colours. Some of them are more of a yellowy colour, and some of them are quite brilliant blue. So often you get a lot of really great colour in a colour image of a cluster as well.
Yeah, I'm still waiting for. We still haven't had anyone deliver a nice colour view of a globular cluster yet. Globular, there, I said it. You happy?
Hard.
I know.
These suckers really are hard to get any color out of, and part of what you're dealing with is you're mostly only seeing the brightest stars in the system, and they all tend to be in the same region of the Hertzsprung-Russell diagram. These are the giant stars, and it's only as you get to bigger and bigger telescopes that the faint red stars start to be apparent. Now, what's kind of awesome is this one looks so much bigger in the field of view than M53 did, and the reason it looks so much bigger is it's half the distance away, so it's kind of cheating. But this is actually one of the systems I studied in my research, and it's just completely filled with variable stars, which means from image to image to image, there's 133 RR variable stars that are dramatically changing in color over the course of one night. Not color, changing dramatically in brightness over the course of one night. So this is one of those great systems to watch.
Could you do like a time lapse of the globular cluster, and you could see the lights, kind of the brightness of various objects going?
There's some amazing movies where it's like watching Christmas tree lights fade in and out.
Yeah,
and they're just very, very beautiful.
Really cool. I gotta find that. All right, well, let's go over to the Rosette Nebula. Gary.
Yep, gotta unmute me. This is the last time we're going to see it this season.
Oh. It looks totally different. It's definitely, I can see what you mean. It's pretty low to the horizon. Yeah, there it is. Yeah.
You can see I'm just barely shooting over the wall of my observatory.
Yeah.
So this baby we're not going to see till spring again.
Oh.
Or no,
till spring or till like winter. Like when will we see it again? Winter?
Well, 6 months it should start coming up in the east.
Yeah.
About this time.
Yeah. Bummer.
That's okay. There's plenty of sky out there waiting to be looked at.
I know. There's all kinds of things we can see.
So this is a great but being consumed by the atmosphere nebula, where what's awesome is we can actually see the atmosphere starting to eat red light. When you're looking at an object straight overhead, as light passes through the atmosphere, a lot of the blue light gets scattered out. This is why we have a blue sky. But as an object gets closer and closer to the horizon, its light has to pass through much more atmosphere, and the probability that the longer wavelengths, the redder colors from the rainbow, are going to get consumed by the atmosphere increases. This is why we have red sunsets. And so as this object sinks, its light is getting scattered to Kingdom Come and not into the telescope where it would be useful. But this really allows us to start making out the globular cluster and the open cluster in the upper right-hand part of this nebula, and we can still make out the termite trails that are actually dust and gas throughout the system. I just love how this one, it looks like termites were eating it, and no, that's just places where the gas and dust have all condensed.
Oh, that's fantastic. Bye-bye, Rosette Nebula. I just, like I said, it was probably, about 3-4 months ago or so, Gary brought that up for the first time, and it was just stunning. I mean, so much more delicate and so much more of the sort of nuance in it. Just amazing. So
if we could just get rid of this pesky atmosphere we have, this is great.
Yeah.
Yeah. Let's launch a telescope. Cool. So what have you got next? We're going to try the monkey head, and before we lose that as well.
Yeah, I'm going to try a quick look at the monkey head.
All right. Let's go back to Saturn while we're waiting. So Stuart, do you think you could get? Oh, your view is kind of settled down a little, Stuart. It looks a lot better.
Yeah, it's the I think the temperature of the scope is equilibrated a bit.
Okay.
And so you can see those atmospheric variations, though.
Right, and also while you were talking, I was fiddling with the exposure and the gain and stuff, and so I got a better image, I think.
Yeah. Yeah, no, it's good.
That's a fantastic image you've got going on. You can almost see the three-dimensionality of the rings actually around the gaseous planet itself.
Yeah, it's the shadowing.
I'm taking a video of it now, so I'll stack it later tonight and hopefully be able to post it.
Now, could you try seeing if we can see some moons? Do you want to try stepping down the brightness or stepping up the brightness?
Yeah, let me see.
Can we come back from that, because this is a beautiful view of the beautiful view of Saturn, right?
Yeah. No, I'm just gonna. Let's see.
And if anyone wants to leave us questions in the comments, Scott and I are both watching the comment feeds.
You watching the one over in the YouTube as well?
No.
I can pull that up.
True.
Yeah, over in the YouTube live version as well. There should be more comments as well. I'm not seeing any moons.
Neither am I. I saw it in my eyepiece. I'm just not seeing it here.
Well, maybe there's something sort of a little above. No, I don't see it.
I can. Yeah, if I brought down the if I stepped, I have it at 14 F14 right now. I think if I brought it down to F7 and made it half as big, we'd probably be able to see some.
Right, they could be sort of further away. Yeah. Yeah. Last week we had we could see 4 moons.
Yeah. Yeah, that was with
yeah.
Yeah. That wasn't with mine.
No, that was with Mike's telescope, his 14-inch.
Mike's, right.
Yeah. And I think, now you've still got, is the moon up for you at all? Because that will be having an impact too, right?
I mean, that shouldn't be really. I mean, Saturn's bright enough that that the moon shouldn't really make that big of a difference on it.
But maybe for the moons, right?
But it's still real low for me. Perhaps.
How is your seeing?
Perhaps.
I mean, your seeing looks pretty good. Is it pretty clear tonight?
Yeah. It seems pretty good. I had some wispy clouds earlier tonight, but it seems real settled down. I'm sort of looking forward to seeing these images that I'm capturing.
Yeah,
right now.
I think they're going to be.
Because I don't normally see the Cassini. Yeah, I don't normally see the Cassini division like we're seeing here with my video capture. I only really see it after the rendering. So.
Well, you're a little bright again, I think, then for us to see Saturn.
There should be.
Oh, there we go. Yeah, that's it.
Oops.
Whoa.
Yeah,
now
sorry.
It's a UFO.
Yeah.
The awesome thing about Saturn is you can always tell if your telescope is no longer pointed the right place, because if people look through the eyepiece and they don't go, whoa, then you know you screwed up. So it's just great that way.
When they look and they go, is this for real?
Yeah.
Well, I'm sitting at...
Yeah.
Yeah, I'm sitting out... yeah. Right. Well, I'm sitting in my driveway right now, and people are walking the dogs, and as I have it on mute, they're looking over my shoulder and saying, "Oh, this is cool. That's Saturn." So that's neat.
Yeah. That's the upside of, I guess, having to do your astronomy in the middle of the road.
Yes.
Okay, well, let's switch over to what Gary's got then. So we've got this is again. Oh, nice. You've rotated it nicely, Gary.
Yeah. I don't know if you saw that Howard put a picture up that compared this with actual picture of a monkey.
Yeah, I'm going to see if I can find that to pull up.
When we first saw it, I was looking at the eyes up in here and the mouth. And as soon as he put those two together, I understood. This is an eye right here.
Yeah.
This is an eye. Here's the mouth. Here's the forehead. It's a monkey.
Yeah.
There's absolutely no question about this.
Yeah, when you see that picture side by side, it was unbelievable, because I guess Howard had found an image of the monkey with its head turned in exactly the right way.
Yeah, pretty spectacular.
Yeah, that's amazing.
This one's going to be it for the season also.
Oh, goodbye, monkey head.
Just slightly higher than we were before. This is all in the Orion area, and it's just disappearing behind the horizon.
Yeah. That's amazing. Oh, Peter, you had M81. Can you bring it back for me?
Yeah, here it is. I'll just pop it up for you. I've got clouds incoming in New Mexico.
Oh, do you? Okay, all right.
So, I'll show you the sky interferometer. Which is,
so here's the image of the monkey head and a monkey. So this is. So now you can really see. So I guess in this one it's reversed to the one that we're seeing in your view.
Yeah.
But you can really see. I mean, absolutely, no question. Someone painted that photograph of a monkey into the sky.
I wonder where Howard pulled that up. That was just amazing.
Yeah.
So what I'm wondering is if Google image search is actually good enough that you can feed it the nebula and it gives you back a monkey. And this is an experiment that I really, really want to try, but I'm not going to do it during the hangout.
So Peter, what do we got here?
So this is M81. This is, again, another Messier object, and you can see how some of these objects could have been misinterpreted as comets, and that's why Charles Messier put the catalogue together. So this is a spiral galaxy. And on Carnival of Space this week, my entry into the blog Carnival that goes out every week from all the different astronomy and space bloggers, I've got a stunning colour photo of this one, M82, which has been put together. It's a 4-pane mosaic of M81 and M82 together that a friend of mine, who's got a lot more time than I have, put together a 12-hour exposure of the two of them into a mosaic image. It's quite spectacular. So anyone following Carnival of Space this week will get to see that. But it's a great galaxy, and it's very, I think you can all see it there.
So, I mean, I think I can even see some clusters in the spiral arms.
Mm.
You can see the dust lanes in the spiral arms.
Yeah, I think you're probably making out the dust lanes more than anything else, the knots of star formation rather than...
Yeah.
So like the Great Carina Nebula is this giant mass of all sorts of clusters and all sorts of different things. And what I think you're seeing is more the scale of the Carina Nebula than of like bland, normal open cluster or the Rosette Nebula that we just looked at.
Mm. So it's quite a stunning galaxy, that one. Very nice.
It is. The symmetry even of the spiral arms, they're just perfect almost. Even though everything else out there is perfect in its own way. It really is just phenomenal the way that it's shaped, as if it was just plucked out of the sky and placed there just so we could see it just so.
You can definitely tell it's not the same as the last one, though. I mean, M51 is this beautiful grand design. This one, it's not truly a flocculent spiral. You can make out two arms on it, but those arms are so much more tightly wound. The nucleus is very different in size compared to the rest of the galaxy, and this starts to give you a real sense of why astronomers have struggled to define all the different types of galaxies by their shapes.
Fantastic. And Gary, what are you getting queued up there?
This is M67, an open cluster. Since we haven't looked at many of those, I thought that'd be nice to shoot through in passing.
That's good. Where's this one located?
Oh, good question. It's definitely, I'm moving higher up in the sky. Where'd my mouse go? You can see I'm pointing a little higher up, so I'm getting better info. It's in, I'll tell you, maybe. I pull up my sky chart.
This is a cluster that I inadvertently rediscover every single year because I always forget where Cancer is. And I'll set up my camera taking a series of photos or just be scrolling around with binoculars. I'm like, oh my God, what is it? Oh, I discovered that last year.
That's great. Yeah, we still haven't had a good color view of these open clusters, and I find that's when they look really great, right? When you get the different colors of the stars. Same with the globular clusters. I mean, with the galaxies and the nebula, you can really see them in just the black and white. You can really see the texture in them, especially galaxies.
Yeah.
But with the open clusters, I find to really appreciate them, you want to see them in color.
Well, and again, with these, the irony is most of the telescopes taking pictures of them are only getting one part of the HR diagram. So most of the time you look at them, and where globular clusters look white, these look distinctly blue because they are still rich with blue stars that are very, very young, although M67 is probably one of the oldest open clusters out there that we can look at.
I mean, it's almost starting to get to the point now where it's starting to fall apart, right?
Yeah, it really is. It's not as bad as like the Hyades cluster where you're like, I think there's a cluster over by Taurus, but you can definitely tell this is much more spread out, which actually makes it a perfect homework assignment. So if any of you ever do a project with me through Swinburne Astronomy Online, this just might be the cluster you end up doing your own color magnitude diagram of because the stars are easy to separate. So it's a kindness and a cruelty all at once.
You two can discover it all your own.
Yes.
Yeah.
Yes.
That's great. And I think we'll go back to Saturn for a little bit. Now you've gone black and white. Something different going on here, Stuart.
Yeah, I turned off the bearing pattern just because it takes better pictures that way. I'll turn it back on real quick here.
Oh, okay,
Just
okay.
while you're talking with Peter there, hang on.
Yeah, because I can see like.
There it goes.
Oh, okay. Yeah, no, you had there was a some kind of grid over top of it or something.
Well, that's just the pattern in the camera, and to what I find when it takes better pictures is if I turn off the color on the camera, the data is still there, but it integrates faster, and then I put the color back in when I stack it in Registax.
Right.
But
you're not changing.
Someone talked to me once, and it seems to work.
But you're not changing filters at all, right? I mean, you're not doing like a red and then a blue and then a green. No, you're just doing pure
No.
full color.
No. Right. It's a color camera, but you can turn off the debayering, and so that the image looks like it's black and white, but the data is still there.
Can you explain debayering? I have to admit that's a term that I've never heard, but I've never used a camera quite like yours.
Yeah, I wish I could.
I've spent quite a bit of time with that. Maybe.
Let me let Gary explain it. He knows it better than I do.
What they do so you can get a single shot color is half of the pixels in the camera are green. So if you look across the first row, it'll say green, then skip, then green, then skip, then green, and then the next row is greens offset by that. So 50% of the pixels have a green color filter over them.
Okay.
In one line, the other ones have a red filter, and in the line below it, they have a blue filter.
Okay.
So you're catching basically 25% of the picture in red, 25% of the picture in blue, and 50% of the picture in green, because that's where the eye's most sensitive. And then to interpolate it, you take the greens and look at the ones around them. If you have a red, you say, okay, well, this is a red. The one next to it came up green, so I'm going to look at the reds to the side and interpolate those. So when you see it with the bare filter turned off, you'll always see that mosaic pattern, because the different pixels are always catching different levels of light in red, green, and blue.
Right.
So you'll see that particular pattern come up. I just know this because I've written a lot of software to do interpolation of this.
Oh.
Right. And the other thing is that every camera has their own Bayer pattern, and so you have to know the Bayer pattern of the particular camera that you have. So it might be RGGB or RGBG or whatever. And if you don't know, if you have it set wrong, your color is going to be all off.
Okay.
Very all off.
Wow, that's a lot to think about.
Right, so you just have to know what the bearing pattern of your particular camera is, set it once, and then you're done.
So what I find interesting about this is, I suspect Gary and Peter have figured this out as well, is different filters let through different amounts of light. And so like blue filters, it feels like you have to expose 4 times longer than you do with the red filters. And I just wonder what they do to compensate for that, to get all the pixels essentially with similar what's called quantum efficiency, which boils down to handle light in the same manner.
And we've been joined by a ghostly Ray Sanders.
Hey, Ray.
It's dark in the observatory, guys. I didn't want to interrupt the discussion on filters, so I just kind of stayed quiet and observed. Anyway, sorry about being late, Fraser. I totally screwed up on daylight savings. Here in Arizona, we don't observe that mythical thing. So,
so the trick is, if you subscribe to the CosmoQuest newsletter, which you should, there's a link next to every one of the different events, and it gives every single time zone if you follow the link, including Arizona. So we're compensating for your crazy by providing a link to your time zone.
Well, it's tremendously complicated trying to tell time across the whole Earth, with including time zone changes and daylight savings time. It's awful.
You should just standardize on UTC. Just call it good.
Yeah. Now, have you actually got a telescope going?
I do, actually. I've just got it set up. I've got it on the moon right now. I was actually trying to flip over that and make sure that it was set up on that. But, yeah, I can punch it up on some other stuff, whatever we have. It looks like we're short on telescopes tonight. I can see why you wanted me to get jumped in.
Well, we're not doing too badly, but yeah, if you can put it in the moon, that would be great. I mean, just to show people the supermoon, or I guess the day after the supermoon, the post-supermoon.
I think at this point in time, the supermoon has gone back into the telephone booth and removed the cape. So now it's just what, Clark Moon?
Clark Moon, regular moon.
I have this great comic that I have to share based on that comic.
Hold on. But yeah, if you want to switch to your telescope view, that would be great, Ray.
Yeah, I'm working on it right now.
Not that we don't appreciate your haunting ghostly
No, trust me.
There.
The view through the telescope is much better than the view through the webcam, so I'll flip it over.
That's adorable. And I think
so Pamela, just coming back to the point about the filters and the cameras, so each camera has its own unique sort of profile of the sensitivities of color. So there are plethora of cameras on the market, and some of them are more sensitive at the red end, and I think there's even a depleted one that's got, I can't remember the exact term, but it's much more sensitive at the red end of the spectrum. And depending on your camera chip, when you're buying a CCD camera and you look at your specifications, it will give you kind of, if I can draw a chart like a little bell curve of the frequencies and how sensitive they are. And then it's even more complicated than we talked about, because even with the seeing in the sky actually, what we air air mass, which is the thickness of the sky, so right overhead it's the thinnest, and as you go towards the horizon the air gets thicker, and it can attenuate different frequencies at different air masses. So variable star astronomers and particularly exoplanet researchers actually run charts and massive complicated spreadsheets that show the sensitivity of their equipment and how that attenuates depending on the air mass. And they, you've got the chart right there. That's the one I was looking for. So on that chart you can see there's a blue sensitivity line, a green and a red. And each of the filters correspond to certain frequencies. So, for example, there's a number of types of filters. There's the Johnson series, and then there's the Cousins series. And each of them have a particular shape that cover a range of frequency, and then the sensitivity of the camera to that frequency. And then when you get into the narrowband filters, the width of those little bumps you can see there narrows right up because they're very tight bandpass filters.
Oh, I think we've lost him. Well, let's.
I'm still here, but I'll let Pamela have a go.
Oh, I was just gonna switch to what Gary's had a great view of a tiny little nebula on his screen for a little while there. So.
This is
That's the Owl Nebula?
Yep. And there's another galaxy we've got down here in the corner. But now that we've got it, I'll zoom in a little bit on it.
You can see the eyes.
Yep. That's the owl.
I love this system. I took an image of this when I was in graduate school, being highly abusive of the 107-inch telescope. It's just this stunningly beautiful little system, and I did take the image while it was still twilight and it was not yet dark enough to see what I was supposed to be observing. But it's just absolutely adorable and really, really tiny on the sky.
Are you able to center that, Ray? Are you still battling your telescope? You got sort of a green moon.
It must be made of cheese.
Yeah.
Really bad cheese.
Blue, kind of a blue color right now. Now there's two of them, and it's surrounded by a balloon. All right. Excellent. All right. So we'll probably go for about another 10 minutes or so, and then I think we could probably wrap things up. So I don't know what. If anyone else has got something they want to show us, or we'll just gaze at Saturn.
You got another new one we'll try here in a minute.
Sure.
Go ahead and look at Saturn.
One thing that I want to try is I have a focal reducer, and I want to try with the focal reducer with my digital SLR to get some deep space objects. You know, it won't be like to Gary's quality, but I'll be able to expand my repertoire a bit and be able to get some of the globular clusters and nebulae. And so, Fraser, you know, one day offline, maybe you and I can test that out one day.
That'd be great. Yeah. No,
works.
I mean, like I said, we had a few hints at it. Roy was able to get some open clusters with his color camera, and that was perfect. I mean, we're getting to see the beautiful color variations. Once you get like the blue stars and the red stars and the white stars and just these different colors, then it was really great. And I find that that's what really makes an open cluster really pop. So that's what I want. When it's black and white, it's just harder to make it out. And same with the globular cluster. So
Right.
I can't wait.
Right.
You stop laughing at me saying globular cluster. I can see you giggling, Pamela.
My husband's Canadian too.
I know,
It's all good.
Cool. All right. So what are you trying to get, Gary?
That's a 10-second of the Crowbar Nebula and the Herring, or excuse me, Crowbar Galaxy and the Herring Galaxy. Let me see if I can center them a little bit better.
I can see like a little line.
Yeah,
This is
I was
one
trying to
right
figure out if
here.
that's what we're looking for or if that's an image artifact.
And this is the other one. Let me give a 60-second and we'll take a look at it.
And so I guess this is what the Owl Nebula is supposed to look like when you have your own Hubble Space Telescope.
Well, this is the 107-inch at McDonald Observatory. So this is what happens when you let a graduate student alone on a telescope and you have twilight skies with a cool little tiny nebula.
So you took this?
Yeah, this is me.
Awesome.
So this was done, this is in a blue filter, an infrared filter, and a red filter. So I mapped red to green, which is what produced the Bizarro Land colors. But those were the three filters that I was using for my research. And yeah.
That's great.
That's wonderful. And it's a great telescope.
It really is.
Nope, we got two Scots.
We have
sharing-
series.
Are you sharing a photo that you took?
This is my supermoon from last night. My first attempt at astrophotography, because I deal more with, the physics part of it rather than the optics and taking photos. But I'm actually proud of this. This is with a webcam and binoculars.
Oh,
So,
wow.
For all of those who think it's way too expensive to get into the telescopes, which it is for me, but you can get a nice pair of binoculars. I got mine for under $100. My webcam I got on sale for $50, and this is last night's supermoon at, I think it was 720p was the definition that I was actually able to get at. But that was my image last night through the haze. I had to mess around for about 10 minutes to get the picture right, but that's
Now,
my
did you
first
stack
attempt.
it? Did you
No,
stack it at all, or
I-
so this is just one frame of it?
That is just one frame that I
The
took.
moon is so bright.
Yeah.
No stacking required with the moon.
Yes.
So
Well,
you
no,
were
but I mean-
using a tripod?
Yes, I had a tripod, and based on the trees in the apartment in my area, I had to put the tripod on top of my car
Oh, gee.
and my laptop on right by the sunroof there and get it all set. But I had to go with power lines and then a tree, but I got it just right before it was being cut off by the buildings.
That's awesome.
No, it's
Congratulations.
fantastic. And so what would you do? You had one eyepiece hooked up with the webcam and the other eyepiece you're looking through to
This
sight
is
it?
This is an afocal shot, so it's not like I'm doing prime focus where I have the... I didn't do any surgery on my webcam because I just got it, and I don't like doing that if I don't have to.
Right.
But yes, all I did was I took actually a paper towel to make the diameter bigger on the webcam to fit inside the eye shield on the eyepiece, and then use some electrical tape to keep it in place, centered where I need to be, and then took some time to tweak with the light settings.
That's
Yeah, that-
awesome.
Yeah, that really sounds like
And
the,
I actually tried to stack.
Go ahead.
Oh, go ahead.
I tried to stack Scott's image today, but I tried to convert it over to a file type that Registax would like, but for some reason there was some codec problem with it, and I couldn't get it to work.
Well, it's a Microsoft webcam, so Microsoft loves WMV. Registex does not. And
Right.
I didn't have time to play around with other software. I got it, and after our Supermoon hangout, I ran outside to get some images. And so even with the stock software, I'm pretty happy with what came out with it. So I can only try for better things in darker skies. So next time I go out to Joshua Tree, I'll try for some better objects like the Orion Nebula.
Welcome to the dark side.
Yeah.
I'm feeling it. I'm feeling the itch already, and it's bad.
Yeah.
All right, so this might sound like a stupid question, but I have to ask Pamela and Scott,
Yeah.
how are you able to have a screen share and your chat up at the same time? Are you guys using two separate browser windows, both logged into the Hangout?
Two separate computers.
Yes.
Ah, okay.
Yeah, so
I haven't...
Ray, we haven't done any sort of experiment, any testing, so you just kind of joined this. But you and I should sit down and we'll go through all the methods and process, and we'll get to sort of, we'll figure it out, because I think it's still, you've still got it in your window, and we want to have just black sky.
Yeah, we'll get there.
This just looks like a computer. A computer is taking these pictures.
So we have in the comment thread, Pete Moison is saying, is the Owl Nebula similar to the Dumbbell Nebula but viewed from the side? Well, we can't tell you about the geometry, but yes, these are both planetary nebula. And one of the crazy things about planetary nebula is they all look slightly different due to what's orbiting the star as it loses its atmosphere. So if you can think about it, as our sun gets old and starts to puff off its atmosphere in its dying days, the planets are going to be whipping through that dispelling atmosphere, creating all sorts of crazy gyroscopic patterns in it. So if you ever played with one of those toys with the wheels inside the wheels, the spiral graphs when you were a little kid, the planets are essentially going to do that to the gas coming off the sun, creating one of those in the sky. And so planetary nebulas, you get that. If there's planets, you sometimes get them pinched off like an hourglass if there's a diffuse disk. All sorts of different crazy things happen, and we're still working to understand the geometries of planetary nebulae.
I think this is sort of a good way that I think we can wrap this up. One last shot of Gary's view. You can see the two galaxies there for sure.
Yeah.
And, we're quite ominous here. I'm going to switch to Peter's view. And so Peter's got this great all-sky view of where the observatory is, and you can see the domes just over on the side, and you can see the clouds. I don't know if you can tell, that whole sky is just clouds all over the place there.
Man.
So that's it for Peter. So
we got lucky.
Yeah.
So if you just want to have a look at that, I'll show you the all-sky interferometer there. What happens when you're doing a remote observatory is you have an all-sky interferometer which measures the sky temperature. I don't know if you can see that. This is showing back to the front in the window at the bottom there at the moment, but I think on the final version it comes out okay. You see where it's yellow and it's gone down and become white, and then just at the end it kicks up to yellow again, and that's where the cloud came in. So the white bit was where we were filming before, which we got a few images for you, and now it's kicked up back to yellow again. What we have when we're remotely driving telescopes is obviously a rain sensor and an all-sky interferometer to measure the temperature of the sky, to see whether there are any clouds over, and then the all-sky camera as the backup. So
goodbye, clear skies. All right. Well, I think we'll leave it on Saturn. So if anyone's interested, we're going to be recording actually probably a double episode of Astronomy Cast tomorrow because we've got a little bit of a catch-up. So we record Astronomy Cast on Mondays at noon Pacific,
3 Eastern. All the rest of the times are in your newsletter. And we're going to try an experiment tomorrow. We're going to try and mail out an alert 2 hours before the show to anyone who has signed up to have alert notifications go to them through CosmoQuest. So if you want to get an email alert every time we're about to start a hangout, go create an account on CosmoQuest if you don't already have one. They're completely free. We promise not to spam you. And in your profile, there's a little checkbox that says, send me alerts, and we will send you alerts for all of the hangouts.
Yeah, and so because the biggest complaint that we've had from people is they just never know when these hangouts are happening. They feel like they're so random. So now we've got this alert system so that you can get an email within a couple of hours that the hangout's going to happen. Now you're still going to have to then remember to come back within the next couple of hours, but I think this is as far as we can bring you. So
yeah, this is what Twitter's for.
This is what Twitter's for. Yeah. So go to cosmoquest.org and set up a profile there, and in the profile you can set up the alerts. And then while you're at it, you can classify some craters on the moon.
Yeah, and this is what I've been doing the entire evening. I don't have my own telescope, so I'm just using the Lunar Reconnaissance Orbiter as one does. So.
Yeah, that's perfect. Yeah, that's
if you're
your
going to
telescope.
improvise, that's the way to improvise. So.
Exactly.
Have you actually been classifying craters as we've been talking?
Pretty much the entire evening, because I have the hangout side by side with the Moon Mappers window. And what's really awesome is there's actually a YouTube player on Moon Mappers such that you can play through a YouTube stream that we have that includes a variety of different shows. I'm going to update it in the morning so that there's some new shows to look at. And it gives you a chance to watch what's going on, do some science, and just learn and do science all at once. And that's really what CosmoQuest is all about, bringing you all the different aspects of a research center right in your browser window.
It's like having the best documentaries in the world while you're actually doing
work.
Yeah, so seriously, how much better does it get? Do science and watch
at the same time. Okay, well, thanks, everybody. Thanks to all of the astronomers.
Fraser,
yeah, Gary?
Before you disappear, throw mine up real quick.
Sure.
If you don't mind. As you can see the name, this is the Crowbar Galaxy right here, and this is the Herring Galaxy.
I see it. I can see the fish, and I can see the crowbar.
Yep.
That's great.
So now I'm going to have to research those and find out what they really look like.
Next week, yeah. All right, well, again, thank you, everybody. Thanks for showing up. I really appreciate it. Thanks to all the astronomers for dedicating their time and showing us the night sky and braving the cold weather, although it's kind of warming up for most of us now in the northern hemisphere. So,
I was going to say, is this where I
all
say
right.
it's
about Thank you.
80 right now?
Yeah, exactly.
And it's 10 o'clock at night. So. All right, thanks, Fraser.
All right, thanks, everybody. We'll see you later.
Good night, y'all.
Good night. Thank you all.